Hello, AP Physics 1. Here is problem number 1 of the multi-body systems homework. Question 1, it says determine the acceleration of the system and the tension of each rope. So you have a multi-body system here. There are two objects. One is 12 kilograms and 10 kilograms. So you should be able to observe and kind of predict that the 12 kilogram object will go down while the 10 kilogram object will go up. So let's go ahead and create our free body diagram. Each of these objects are going to get two forces each, okay? So the 12 kilogram object is going to have tension going up and gravity going down, MAG, which points down for object A here, and then tension going up, okay? And then for the object B, we're calling the 10 kilogram object B. It's got tension going up and force of gravity going down, okay? Force of gravity for us is just MBG. We're going to say that towards the bottom of the screen or the page is the positive y, okay? So before we continue any further, take a look here and make sure you understand this, okay? So one more time, this is object A, this is object B, right? They both share the same string, so we're going to call both of these tensions up T. They're both the same amount of force. They're along the same string. They have the same amount of force. What's different between them, though, is the force of gravity, right? This is heavier, so it's going to have a higher force of gravity, but we're going to just represent it by saying MAG. That's it. So next thing you got to do is write your Newton's second law equation, right? So in order to do this, you have to say sum of the forces in the y direction, right? That's how we usually do this. But for object A, okay? Because we want to sum the forces for object A, all of the forces in the vertical direction. And we're going to set it equal to, well, MAG. We write this first, right? Because it's the positive force, right? We are the ones who determine where the positive direction is. So we are determining that towards the bottom is positive y. So in that case, we're going to say that MAG is the positive force, right? So we take that subtracted by the negative force. What is the negative force? It's tension, right? Ignore the yellow arrow for now. That's for later. But so far we have MAG minus T. Okay, MAG minus T. And what do we always do? Set it equal to MA, always. But not just any MA, right? Mass of A. So again, before we continue any further, take a look at what we got so far. Make sure you understand this, right? MAG minus T equals MAA. This is a multi-system problem, so there's going to be another equation, but for object B. So let's go over here and start writing the same thing, but for object B. So the way we started, again, sum of the forces in the y direction for object B, right, is equal to, you guessed it, instead of T, instead of, what you want to call it, MAG minus T, now it's MBG minus T, okay? So it's pretty much the same thing, but keep in mind, right, this is still the positive force. Even though the system's going to go like this, right, the 12 kilogram will go down and the 10 kilogram object will go up, we're still going to write MBG minus T the way it is like that, because MBG is the positive force. It's the one that is pointing downwards. And then what did we do? Always set it equal to MA. Very important note, right? Because the acceleration of the 10 kilogram object is upwards, right? You have to ask yourself, where is it moving? So the 10 kilogram object is moving up. In our system, that is considered the negative direction. So you have to put this negative here. That's something you have to go ahead and do, okay? So once again, for the third time, pause, take a look at what we got, right? Free body diagram, Newton's second law equation for object A, Newton's second law equation for object B. All looks good, right? So what you have here is that you have two unknowns, right? We have tension and acceleration that we don't know in both of these equations. All the other values, they are known values, right? MA is a value that's given as 12. G is always 9.8. So essentially you have two equations and two unknowns. This is called a systems of equations. If you remember this in algebra land, basically the couple of ways to solve it, I recommend that you use substitution, right? How does substitution work? That's kind of where this yellow arrow is coming from. Basically what you got to do is you solve for one variable in one equation first, get that by itself, and then plug it in to the other equation. So if that doesn't make sense, that's fine. Basically, all I'm saying is look here and let's solve for the letter T. What does it mean to solve for the letter, right? You have to get it on its own. So we get it on its own by first adding tension to both sides and then adding MBA to both sides, because what that's going to do is that's going to move this guy over and move these two over, right? MBA is going to come over to the other side as well. So we're going to swap places, right? This is going to go here, and the tension, well, that's going to go here, right? You'll see. So once we do that, boom, this is what it looks like. Okay, so observe, make sure that makes a little bit of sense to you. Okay, I'm going to pause right here for a second. All right, for the fourth time, just kind of take a step back, make sure you understand what's going on here. Right, we took this equation, we plus T on both sides, and then we have to plus MBA on both sides. So these two swap places. Now the signs are positive, it's all positive, it's all good. Now this is what tension is. You can literally answer half of the question, right? That's what the question wants. What is the tension? Right, you can plug in MB, which is 10, G is 9.8. However, we still don't have A, so you're actually not done yet. But what you're going to do is literally take all of this and plug it into there. You're going to substitute it in. Once you do that, it's going to look like this, right? MAG minus all of that stuff that we just wrote, because that's all tension, still equal to MAA. You see that? We took all of this and shoved it into here. Now, another thing you got to keep track is that this negative sign, you got to apply it to both of these, okay? Because you're subtracting by the whole tension. That means it's going to be minus MBG minus MBA, okay? I know I'm sounding like some kind of weird Morse code person by saying all these letters, right? But stay locked in, okay? We're not done yet, chat. MAG minus MBG minus MBA. We applied that negative, right? That negative, boom, applied there. Get it in there, right? That's what we do. Again, now you can't lose track of the plot, right? Now that we plugged in tension, well, the goal is to do that in order to solve for one of these unknowns, because now all of these unknown values, but let's isolate A, right? A is here, and we got an A here. Let's get all the terms of A to one side. How do we do that? I got to get this guy and move it over here. So, you remember how to do that, right? You just add it, because we want to get this over here. So we add it, just like that, plus MBA. Once you do that, what's that going to look like? It's going to look like this, okay? MAG minus MBG equals MAA plus MBA. Hopefully I haven't lost you yet, okay? We're solving for letter A, so what that means is that we have to factor out the A, okay? You see how both of these terms have A? You can factor it out. Pull that A out. That's what that means. Factor it out. Okay? Once you factor out the A, it takes you one step closer to solving it, because now what you can do is you can... Oh, this thing's not behaving. I'm just going to have to move it. Right? You can divide, right? Once you factor out this term, you can take that entire thing and divide it. Stick it underneath all of this stuff. Right, that's gonna look like this stuff in the green. Okay, we're almost done. After that, boom, this is the best part. All of these are known values. You have all of these numbers. These are not unknowns. Go ahead and plug those in. 12 for MA, 9.8 is G, MB is 10, G is 9.8, MA is 12 plus MB, which is 10. Put that in your calculator and you're gonna get beautiful 0.89. Okay, how's that? That's how you get acceleration. How do we get tension? Okay, let me get the rest of it here. But in order to get tension, right? Well, actually, I'll leave you guys to do this. But that's your answer for A, right? That is the acceleration. You want to get tension? Go back here and plug that for A, and then plug those values in for MBG and MB. You got that, okay? That way you can do on your own. But check it out. All right, no excuses. Get it done, y'all. This is Chin signing out.